Howdy and welcome back. So let's go ahead and get on with our introduction to relational databases. So who got the ball rolling on the introduction of these of the relational databases that we're kind of used to today was Edgar Todd from the IBM research laboratories, and this took place in the early 60s. He was unhappy with kind of the existing database models of the day. So in the 70s, he published a paper, a relational model for large shared data banks. And we'll see this was kind of the theoretical foundation to the relational databases that we use today. Larry Ellison later put Codd's theories to practice and founded a company that you might know today, Oracle. So let's get into, what is a relational database and move away from its kind of history and conception. So relational databases are going to provide structured storage through a collection of tables that is going to house different types of objects and express different relationships amongst its entities. It's going to allow complex relationships to be represented and manipulated using relational algebra on a collection of tables with uniform layout. What we're going to be able to do is specify the underlying structure of how we're going to store these objects very easily, and it'll be through essentially create table operations using the SQL declarative language to interface with these database engines behind the scenes. What that means is we're not going to have to write explicit code to create this structure in these associations connecting different types of records in their persistent storage. Instead, we can set all of this up, and then what we're going to be responsible for in our application is ensuring that the different components of our objects gets distributed to the proper tables within our database. So we're in our applications, we're still going to have to establish the correspondence between the in-memory objects and their persistent counterparts. But what we will see here is the actual setting up of that persistent storage. We're not going to have to write code to do that. And in fact, we'll be able to leverage library code and different adapters to essentially make the hookup from our application to that relational database and allow us to interact with it using this declarative language, SQL. So just to, reinforce maybe how data is structured within these things, it's very similar to how we set things up here with this idea of tables. And in fact, we'll use the terminology tables to describe, say, where students are held in a relational database versus where courses are. And then we can have these join tables that essentially can express many-to-many relationships. For instance, students have many courses, courses have many students. But before we start looking at those relationships, let's just look at the individual idea of a table. So each type of object is going to be stored in a table. A type of object could be a course, it could be a student, a faculty member, a product. It really depends on the context of your application. Now, within a specific table, each row is going to represent an object instance, that is a record. Each column of that table will represent an attribute for that record. All values in one column will have the same data type, for instance, an integer. Every row is going to be uniquely identified by what's going to become known as a primary key. For instance, you can think about these fields having, similar maybe attributes stored within them. For instance, something like names, where two different objects, or in this case, people, could have the same name. How do you differentiate one from another? Well, in a university setting, we could use their UIN. That could serve as a primary key or a primary identifier of a specific row in a table. Now, a foreign key, on the other hand, is going to be a column in one table that references the primary key of an object in another. And this will allow us to establish associations between different records across different tables. I'll get into a couple of examples of this here shortly, and I'll point it out. Okay, so this slide I stole from my undergraduate database course I think it was called like an introduction to databases, but it was taught by Dr. Tom Hicks at Trinity University in San Antonio, Texas. I liked it because it's a little bit retro here. You could see that it's essentially communicating that there's multiple different ways to communicate with these databases. For instance, a lot of web application or web services are going to communicate with the database to store information. For instance, when you're interacting with the CS128 website, who you are is stored within a database. All your submissions to our playground are stored within a database. And we set up different relationships to essentially communicate that, this submission was from you. In addition to that, different services or dedicated applications can also interact with a relational database. And I'll go ahead and point out these are kind of retro. It's a blast to have past. If you look at the web browser, it's Netscape. I'm not sure how familiar y'all are with that, but that was kind of the first web browser I ever used. So it's kind of nostalgic. But anyhow, then the application, bit of a retro interface there. And then finally, the command line hasn't changed too much, but you can actually interact with these relational databases through a command line interface, similar to how you could say interact with your Vagrant virtual machine through the command line interface as well via SSH. So the protocol for SQL interface through the command line will be different, but nonetheless, there's a way to get in and begin interacting, making queries to the database, asking it for things, putting things within it, etc., all through this command line interface. So I guess you could say the possibilities of interacting with the database are endless. We can do it directly, we can do it or indirectly through dedicated applications or even through web so software installed on your machine or web-based applications. And in the dedicated and web-based interactions, a lot of times the queries to that database are going to be hidden from you. So you press a button, you see a result, and how that result's being generated is going to be behind the scenes through SQL queries. Now, the SQL command line interface would be executing raw queries to interact with that database through that sort of interface. So just another, I guess, disclaimer, this slide and the next few were also more or less heavily pulled from Dr. Tom Hicks' slides at Trinity. So database interfaces, let's talk about the server side first. So this isn't like a file that we're writing to. It's not like a plain text file. It's not like a binary file. A database is actually going to be an application that's going to be running as a separate process and maybe even on a separate computer. So we'll be interacting with that database through this query language SQL. We'll send those requests to this database server. It will parse them and then perform whatever operation we're asking of it. So one database server might even be serving out data from multiple databases. It's a whole database engine. Its sole purpose is to essentially field up these databases. Now we will see there are different, manufacturer developers of different databases out there. And we'll see that there are also different standards for how requests can come into a database and also how data would flow out of it. A couple that you may find of interest are listed here below, but the key is to understand that there are different means for going about these processes. Now on the client side, essentially it must interact or be communicating with the database through the same kind of standard here for connectivity. Examples of existing client-side programs, again, we've gone through this, but the whole idea is the client is going to make, so that could be your application, it could be an application, web application, or it could be interfacing with the database directly through the command line. All of these are going to make requests. If you think back to the networking topic in this course where we said we had a client or an application making requests to a server or a service running on it. Same thing's happening here. You might have a remote machine. One of the services might be a database engine. The client would go ahead and make a request to that database engine. And as long as we're speaking or interacting with the same set of protocols and we can understand one another, so the database engine can understand the client and the client this response from that server, they can begin to initiate dialogue and exchange information. Now the de facto, and by de facto, I mean, or I'm using this term in the sense of like a de facto standard. So a de facto standard is a custom or convention that has achieved a dominant position by public acceptance. And that's what I mean by saying that the de facto interface language to databases is going to be structured query language, or also known as SQL per its abbreviation. So it's going to be the standard interface to relational databases. We'll interface with the databases using this declarative language. So we won't specify the actions in terms of statements as to, how we might want some particular information to be looked up in the database and returned to us. Simply, we'll just declare and say, hey, I would like all of the records from this particular table. The database engine would be responsible for parsing that query and returning the result. What we're going to see here is that SQL is going to allow us to create, alter database structure, as well as add or remove records to various tables contained within it. So here's a couple of very brief examples of SQL in action. So this language is going to be very simple. Let's say that our database houses a table called courses, and that courses table has 4 fields: ID, name, number, description. Let's say I'd like to ask the database engine for the name and number, so all the rows in the courses table, but only the name and number fields. I could say select name and number from courses, and the database engine would go ahead and return that information to me. Now let's say that we have 2 kind of tables here. For instance, let's say that we have a faculty table, so myself and Professor Challen, and then let's say we have a relationship to some sort of table that's storing the name of the department that we belong to. So in this case, in the departments table, ID is going to be a primary key. In the faculty table, department ID is going to be a foreign key. It's going to make the association between the department that myself and Professor Challen belong to with that record out there in the departments table. So let's say I'd like to select the department name and faculty name of computer science. So I could go ahead and say select departments.name, faculty's last name, faculty's first name from departments and faculty, where the department ID, so over in the foreign key, is equal to 1, and department ID is equal to faculty.department ID. This last and statement is making the connection between the departments table and the faculty table. That's actually going out, creating that Cartesian product, which we are then filtering based on the idea that we only want the records whose department ID is going to be 1. In this case, we get back the following. We get the department name from departments and the faculties who belong to that department's first and last name as shown below. So this would have 3 fields returned to us and 2 records. So before we continue on, let's just briefly acknowledge some of the commonly used relational database platforms. On the left-hand side, I have kind of small scale things that don't necessarily scale up to production kind of level of interactivity. So think single user or a few users, not a lot of records that would be access, and maybe even a step down in term from that would be SQLite. The more production level relational databases would be things like MySQL, Postgre, Oracle, which would be proprietary. Same with Microsoft SQL Server, which is also proprietary. MySQL and Postgres are both freeware, so you can download them and use them. In this class, we're going to keep it simple, and we'll use SQLite, I believe. Though once you kind of get the hang of SQLite, it's not such a stretch to begin understanding how some of these more production level databases operate. So with that ado, we'll move on to the next section here shortly.